Hey guys, today we're going to be talking some more about rational numbers. Today we're going to be talking specifically about recognizing patterns in rational numbers. So patterns goes right here. Before we get going on our material, I just want to tell you that there is no separate worksheet for today. Today this notes page is your worksheet. So print it out if you want, or you can just get a blank piece of paper and write stuff down on it. But this front sheet, just this first page, is what you're going to be turning in for today's assignment. Okay? So patterns in rational numbers. Patterns are such a cool thing and they can be so beautiful. Do any of you do any artistic things with patterns? I love to do tatting. I don't know if you know what tatting is, but it's like tying a bunch of knots with this little thing called a shuttle. Here's my current tatting piece. I really need to work more on it. It's really slow going and I haven't done much lately. But you can see like there are these patterns, and when I repeat it over and over, hopefully I'll have like a bigger thing and it becomes really pretty the more you repeat it. I also tatted this little bracelet. So just a little show and tell here. But you can see like the more you repeat patterns, the more fun they get, and it's just a beautiful thing. I would love to see any of your art that you might have if you want to do a little show and tell. When you're doing your homework submission, if you have something that you'd like to show me, just take a picture of it and throw it in there with our homework. Totally optional, you don't have to, but if you are an art person, I'd love to see what you got. That's super fun for me too. Okay, we should start with our warm-up. So first of all, the warm-up. Write each fraction in reduced form. So this is kind of like our assignment we did yesterday. So we're going to be simplifying these fractions. So if you have 2 over 8, we need to simplify. So let's see, it looks like 2 will go into both of those numbers. 2 goes into 2 one time, and 2 goes into 8 4 times. So that simplifies to 1/4. What about 5 over 15? Well, both of those numbers are divisible by 5. So 5 divided by 5, I'll go ahead and write it out. 5 divided by 5 equals 1, and 15 divided by 5 equals 3. So that becomes 1/3. You just want to make sure you divide the top and bottom number by the same number. What about over here, 15 and 45? Well, we might do this in a couple stages. It looks like both of these are divisible by 5. So divide that top number by 5 and you get 3. Divide that bottom number by 5 and you're going to get 9. But look, these two numbers are still divisible by 3, so let's take it one more step farther. So we're going to divide both of them by 3, and you'll get 1 over 3. And now at that point, that's fully simplified. One more of these, 6 over 9, both of those are divisible by 3, so 6 divided by 3 gives us 2, and 9 divided by 3 gives us 3, so it looks like 2/3 is our final answer there. All right, now on E through G, we're going to just go from decimals to percents. We didn't talk about this at all yesterday, but maybe it's something that you learned earlier in your school career. Just as a reminder, when you're going from a decimal to a percent, you're going to move that decimal point 2 places to the right. So our decimal starts here. To change it to a percent, we're going to go 1, 2. So our decimal is going to wind up here between the 7 and the 5. So this is going to be 37.5%. What that means is the decimal 0.375 and 37.5%, they are equivalent. They mean the same thing. Just two different ways to write the same thing. So let's try F. Again, we're going to be moving the decimal place 2 places, the decimal point 2 places, that is. So the decimal is going to wind up here, and so that is going to become 90%. So 0.9, 90%, they mean the exact same thing. All right, in this one, we've got a 1 out in front, but that doesn't change how we do this. We're still going to take that decimal and move it 2 places, so it's going to wind up there. So our final answer there is going to be 105%. Okay, now let's do a few other things. Write 1/3 as a decimal. So you may remember from yesterday, these are just basically division problems. So you're going to have that 1 divided by 3. Make sure the bottom number goes on the outside. Now a 3 doesn't go into 1 at all, so you have to do the 0.0 right there. You remember how to do this, and then there's that point up there as well. 3 times 3 is 9, and then you have a 1, and looks like you do this again, and you could do this all day long if you wanted to, because it's a repeating decimal, and the way we write that is 0.3 with a line over it, means repeating forever. Okay, 1/6. Let's write it as a decimal. So 1 goes inside the little thing and 6 goes outside. 6 won't fit inside 1, so we're going to do 0.0 there as well. It goes 1 time, so 1 times 6 is 6. That leaves 4, and now 6 times 6 is 36. So let's do that, and then it looks like we're going to be repeating again. So we have 0.16666 repeating forever. So it's just the 6 part that's repeating. So we're going to go 0.16 and just put that line over the part that repeats. In other words, just over the 6. And that would be your answer there. Okay, let's go on to J. Now this one has an equation, a one-step equation. You guys know how to solve this. You're going to need to get rid of the 26 by dividing by 26 on both sides. Now how is this different than what we've seen before? Because it's not going to be an integer. It's not going to be one of those nice numbers. Let's figure out what it's going to be. So if you have x equals 12 over 26, okay, that's looking good, except we do need to simplify it. Both of these numbers are divisible by 2, so let's divide them both by 2. And that's going to be 12 divided by 2 is 6, 26 divided by 2 is 13. So it would be x equals 6 over 13. Now, if you needed to write it as a decimal, well, you don't have to, by the way. But you might remember this problem from our assignment yesterday. 6 over 13 written as a decimal, it gets a little crazy. So let's go ahead and do it really quick. So 6 divided by 13, sorry, let me just block this off. And you don't have to copy this down if you don't want to. Okay, so 13 goes into 60 how many times? 13, 26 times 2 is 52. Okay, so 4. 4 times 3 is 12. 4 times 1. So there we go. That took a little bit of thinking. And I forgot my decimal point up here. Let me catch that. So it's 0.4. 4 times, and then now we subtract, and you get 8 there, and you bring down your 0. And now how many times is it going to go into 80? Well, actually, hang on one second. Sorry about that. That was going to take me a little while, and I didn't want to waste all your time. So I just went ahead and worked it out, and it's going to be 461,538, and then all of that is going to repeat. So basically, your decimal here is going to be 0.461538, 461,538, 461,538, and that is going to repeat forever. Told you we're talking about patterns today, right? So how can we handle this? You're going to just draw that horizontal line over those 6 digits that repeat. So I am totally running out of room here. I'm just going to write it right here. 0.461538. You put your line over that entire thing, and that is your answer with that decimal point right there. Okay, if you have questions about that, let me know. But you're just going to put a line over those digits that do repeat. Let's keep going. It says part of being comfortable with fractions is knowing how they work. They're little division problems. Okay, and how to count with them, just like we count with regular numbers. You know how you can count by ones, or count by fives, or count by tens? We can learn common fractions using count bys. And when we say count bys, that's what we're talking about. Counting by ones, counting by twos, counting by tens. So count bys. Just like you may have used them to learn times tables. If you pay attention, you're guaranteed to see fraction patterns and properties that you have not noticed before. It says work with a partner, sad. Consider me your partner if you want, or work by yourself to complete the following table, counting up for each denominator until you get to the equivalent of 1. Reduce fractions when possible, or simplify your fractions, whichever way you want to say that. Write both the original fraction and the reduced form. Okay, let's work on this together. So we've got this big table here and a lot of blanks in it. And if you are writing this on your own paper, you might need to pause for a second and just get this all kind of written out. Or you can write it as you go and just pause as needed. That's totally fine too, of course. Just make sure you save yourself plenty of room. Let me zoom out. Speaking of plenty of room, there we go. That's looking a little better. Okay, so first of all, you've got 0 over 1 here and 1 over 1 here. Okay, so let's look for our pattern. Then we have 0 over 2, 1 over 2, and 2 over 2. Okay, so it looks like the top numbers are going up by 1 as we go down. So we have 0, 1 here. Here we have 0, 1, 2. And here we have 0, 1, something, 3. So it must be 2 on top here, right? What's going on with those bottom numbers? We have 1's here, 2's here, 3's here, so it must be 3 down here, right? Okay, let's keep going with our pattern. So 0's over here. And what should be on bottom? 1, 2, 3. Looks like we should have 4 on bottom here, right? Okay, let's keep going. 0, 1, 2, 3 fourths, and then 4 fourths. Okay, now we have fifths on bottom. We have 0, 1 fifth, 2 fifths, 3 fifths, 4 fifths. And guys, I know it's hard to look at the screen and look at your paper, so again, pause this as you need to, okay? Over here we're doing sixths, so we have 0 sixths, then we have 1 sixth, 2 sixths, 3 sixths, 4 sixths, 5 sixths, and there's 6 sixths. Now let's do our sevenths. They've written 1 seventh for us. Now here's 2 sevenths, 3 sevenths, 4 sevenths, 5 sevenths, 6 sevenths, and 7 sevenths. So in that bottom one, you're always going to have the same number on top and as bottom, right? Now we're going to do our eighths. 0 over 8, 1 over 8, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, and 8 eighths. Now we're going to do ninths. 0 ninths, 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths, 6 ninths, 7 ninths, 8 ninths, and 9 ninths. And now finally our tenths. So let's start with our 0 over 10. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths. Whew, okay, that was a workout, especially for you guys who didn't have that printed. You got to write it all, but you know what? That's just extra practice, and it's so good for you. So now we're going to go through and kind of simplify all of these fractions and kind of look for patterns as we go. So first of all, 0 over anything is going to equal what? It's going to equal 0. It doesn't really matter what's on the bottom. It's always going to equal 0. So right all the way across the top, I'm going to say everything is equal to 0. Now you see this little arrow with question mark? It seems like our table would need to be extended by 1 and have 0 over 0, right? But actually, we can't do that. Do any of you know why? This is a big old fat no. You can't have anything over 0. 0 can never be in the denominator because you can't divide by 0. If you have a 0 in the denominator, we in math like to call it undefined. It basically doesn't exist. You don't have it, so you don't have to worry about this one. All right, let's keep simplifying what we can find to simplify. So let's see. These are simplified. This one, can 1/2 be simplified? No, it's just 1/2. 2 over 2 is simplified for us. All right, that's simplified. Can either of these be simplified? Nope, and that is simplified for us. Okay, 0 over 4 we simplified. 1/4, can't do anything with it. What about 2/4? Yeah, both of those numbers are divisible by 2, so that is going to simplify to 1/2. What about 3/4? Anything? No. 4/4? Yes, that's going to simplify to 1. Okay, now how about those fifths? Can any of these be simplified? Only the 0 fifths and the 5 fifths. That's it. Everything else is fully simplified as well. How about the sixths? So 1/6, that's fully simplified, but 2/6 can be turned into 1 over 3, 1/3. What about 3/6? What do you get when you simplify that? 1/2, nice. And then 4/6 can be simplified as well. Let's divide both by 2 and you're going to get 2/3. 5/6 is fully simplified and the 6/6 is done for you. That's going to equal 1. All right, now for those sevenths, is there anything we can simplify through here? Nothing through here, but when you get to 7 over 7, what is that going to equal? Yes, that's going to equal 1. And you've probably already noticed every single one of these bottom squares equals 1, right? So along the top we have zeros, and along the bottoms we have 1s. Now let's go to our eighths. With 1/8, that's already simplified, but 2/8, we can simplify that to 1/4. 3/8, can't do anything with it. 4/8, that simplifies to 1/2. 5/8, can't do anything with that, but 6/8, let's divide both of those by 2 and you're going to get 3/4. 7/8, can't do anything, but 8/8, like all of its partners on the bottom, equals 1. All right, now how about those ninths? 1/9, 2/9, can't do anything, but 3/9, let's divide everything by 3 and you're going to get 1/3. 4/9, no. 5/9, no. 6/9, let's divide by 3 and we're going to get 2/3. 7/9, 8/9, can't do anything, and 9/9 is going to give us 1. All right, one more column left. Let's do it. How about those tenths? 0/10 is 0. 1/10 is simplified. 2/10, if we divide both of those by 2, you're going to get 1/5. 3/10 can't do anything. 4/10, you can get 2/5 if you divide everything by 2. What about 5/10? What does that equal? It's going to be 1/2, right? Nice. 6/10, looks like we can divide everything by 2, so we're going to get 3/5 there. 7/10, can't do anything with it. 8/10, divide everything by 2, and you're going to get 4/5. 9/10, it's fully simplified, and then 10/10 equals 1. Phew, okay, that was a lot of work. So now we can do the fun part, which is look for patterns. So as we said at first, you know, all of those along the top, all of these are going to equal 0, right? So if you want to mark that on your paper, you may not have a bunch of markers or highlighters, and that's fine. Just mark your paper in a way that helps you. I need to see all the fractions written, but I don't have to see all the colors. And then for all the ones, like this whole diagonal down here is all going to equal 1, right? So that's definitely a pattern. What other patterns do you see? What about the number 1/2? Okay, so the first time we have 1/2 is here, right? Where's the next time we see it? Here, right? Yeah, and then the next time? Here, and then here, and then here. It's kind of over 2 and down 1, almost like if you were playing chess, if you like to play chess, how the knight moves. Boop, 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 boop. So there's a pattern. What about another pattern? How about 1/3? Do we see that one crop up anymore? Yeah, there's a 1/3 there. And there's a 1/3 there. So it's kind of in an over 3 down 1 pattern. I wonder if 2/3 pops up anymore. What do you think? Let's find out. 2/3 there. Where's our next one? Oh, there's another one. And there's another one. So for 2/3, it's like over 3 and down 2. And you don't need to write down any of these patterns. You don't even have to memorize them. I just want you looking for them and kind of seeing that these numbers recur over and over. So those are some good patterns. You might spot more patterns. If you have more colors and you want to look for more patterns, you should totally do that. That's a wonderful thing to do. But for now, we're going to go down to these thought questions. What did you notice about the rational numbers on the table? Well, we've kind of already talked about that a little bit with these patterns. It says there are a lot of blank patterns. You guessed it. Okay, so it says tenths and blank have a lot of repeats. I feel like it's a little bit confusing the way they said this, but what they mean is like tenths and what other numbers share with each other a lot. And the answer here is fifths. So like you see how 1/5 turns up in the tenths pattern, and 2/5 turns up in the tenths, and 3 turns up in the tenths, 3/5, and 4/5 turns up in the tenths. Hang on one second, sorry. Sorry about that. So basically what we're saying is the tenths and the fifths, they say here that they have a lot of repeats. I like to say they have a lot of overlaps because you find a lot of these fifths in the 10th column. So the answer here is fifths. Now down here, thirds, blank, and ninths have a lot of repeats. Again, I want you to kind of think overlaps instead of repeats. So thirds and ninths, see how there's a lot of thirds in the ninths column? There's there and there. What other column has a lot of thirds? It's this one right here. It's kind of right in between those two. It's the 6th column. And then one more here. Blank, fourths, and blank have a lot of repeats. So you've got your fourths right here. Looks like you've got a half there. And so it overlaps with the halves. And then where else do you see a lot of like fourths and halves? Over here, right? In the eighths? You've got fourth, half, fourth. So we're going to say halves, fourths, and eighths have a lot of repeats. Okay, one more question. Which denominators do not contain the fraction 1/2? And why don't they? So like here you see 1/2 in this column, but there's no 1/2 here. There's a 1/2 in this column, but no 1/2 here. 1/2 here, but no 1/2 here. 1/2 here, no 1/2 here, and yes, 1/2 here. So what's the pattern? It's those denominators that are odd that do not have 1/2 in them because they're not divisible by 2. So the denominators that are odd, I'm just going to write that are odd. And then why don't they? Because they're not divisible by 2. Okay guys, if you have any questions about this stuff, let me know. Again, this first page is what you're going to take a picture of and submit to me. And I'll see you next time. Bye!